All right, so I was just talking for, I don't know, maybe 30 seconds or so, and I didn't unmute myself. But I'm gonna leave it in there. I don't edit anything out. So today we're going to be talking about AI model detects 99% accuracy, chip-based 3D printer, semiconductor tech breakthrough, nerve to cancer transfer of mitochondria, and volcanoes may cough up gold. That said, since I basically derped the first 30 seconds of the show, this is Technology Today, and welcome. So yeah, I'm just going to leave it in there. That's fine with me. So Technology Today, it's basically a deeper science and technology show, and not as broad spectrum as ohmTown overarching Non Sequitur news show, which has 10 articles a day. This is 5, more focused on science and tech. So a new AI model diagnoses brain tumors with 99% accuracy and without surgery. An AI model called CrossNN identifies over 170 tumor types with high accuracy, tumor types, not just tumors, but tumor types, with high accuracy using genetic material, offering fast, non-invasive cancer diagnosis. An MRI scan revealed a brain tumor located in a difficult area, and performing a biopsy would carry significant risks to the patient, who had initially thought medical help would be necessary because of double vision. So it was detected, but they didn't know necessarily what type it is. I think it's Charité. I'm not sure how to pronounce this. Universität Medizin Berlin, Medical University in Berlin, or Berlin Medical University. So yeah, their solution is an AI model that analyzes specific features in the genetic material of tumors, particularly their epigenetic fingerprints, so how they're expressed, which can be obtained from sources such as cerebrospinal fluid, so a spinal tap. They get the liquid, they find basically free-floating cancer cell-free, I should say, what do they call it? CFCs. Yeah, it's free-floating cancer cells. Fragments. And as reported in the journal Nature Cancer, the model classifies tumors both rapidly and with high accuracy. Today, with many more types of tumors are recognized than the number of organs from which they originate. Each tumor has distinct traits, including specific tissue structures, growth patterns, and metabolic behaviors. Even so, tumors with similar molecular profiles can be grouped together. Effective treatment depends heavily on correctly identifying the tumor type. So they look at the genome instead of into the tissue. A new approach that was developed characterized brain tumors, one that moves away from traditional microscopic diagnostics and instead focuses on modifications of the tumor's genetic material or epigenetic features. Hundreds of thousands of epigenetic modifications act on and off switches for individual gene sections, and their patterns form a unique, unmistakable fingerprint. Interesting. In tumor cells, the epigenetic information is altered in a characteristic way. Based on their profiles, they can differentiate between tumors and classify them. This is really interesting. So fascinating. Mainly because we're getting to understand the actual genetic structure of tumors, and being able to classify them means that a more focused treatment is possible. Very, very, very fascinating. Let me do something real quick. Exclamation point TT will tell ohmTown to spit the articles out into the chat, but something isn't right here. Yeah, it says the message failed to send, but I'm connected. Not good, not good. Let me try that again. Pardon me 1 second. Oh, very weird. I don't know what's going on. Well, I'm still streaming, so I'm just going to have to keep moving on. I don't know what's going on with Twitch. So being able to classify them is just a massive leap forward. To match an unknown epigenetic fingerprint with thousands of known cancer profiles and assign it to a specific tumor type, machine learning methods, AI, are needed to basically classify due to the complexity and the size of the data set. Yeah, something weird's going on with Twitch. Somebody else crashed, but I don't know if it was them or if it was Twitch. Anyway, a newly developed AI model goes by the name of CrossNN, whose architecture is based on a simple neural network, and the model was trained with large amounts of reference tumors and subsequent data that was tested from 5,000 tumors. And then they say that their model allows a very precise diagnosis with a nearly 98% accuracy of 170 different tumor types. Not tumors, but tumor types. So pretty amazing. All right. I won't go into all the rest of the specifics, but there is a whole team that is involved in this, and it's posted over at Nature Cancer. The article itself is at Sci-Tech Daily, and you can follow the link through ohmTown, or just go over to Sci-Tech Daily and do a search for AI model diagnosis brain tumors. Let's keep going. The next article is over on RealityHacker. Researchers demonstrate the first chip-based 3D printer. Researchers have demonstrated the first chip-based 3D printer, a tiny device that emits reconfigurable beams of visible light into a wall of resin that rapidly cures into a solid shape. The advance could enable 3D printers small enough to fit into the palm of a person's hand. The article is over at ScienceDaily.com. It's actually sourced from a June 10th article, but just recently published into or aggregated into ohmTown. It says it's smaller than a coin. The optical device could rapidly or enable rapid prototyping on the go of at least small items. But they say here their proof of concept device consists of a single millimeter scale photonic chip that emits reconfigurable beams of light into a well of resin that cures into a solid shape when light strikes it. The prototype chip has no moving parts, instead relying on an array of tiny optical antennas to steer a beam of light. The beam projects up into a liquid resin that has been designed to rapidly cure when exposed to the beam's wavelength of visible light. And by combining silicon photonics and photochemistry, the interdisciplinary research team was able to demonstrate that the chip can steer beams of light into 3D print arbitrary two-dimensional patterns, including the letters MIT. Shapes can be fully formed in a matter of seconds. So this is pretty cool. They don't have a video of it, but I'm sure if you go over to YouTube and do a search for this, you'll be able to find it. But if it's small enough and high enough resolution, then smaller elements can be created. I think micronization is going to continue, and we're going to find that we can get down into fabricating nanoscale stuff easily, but that technology will have to eventually get there. Weird. So many things are going weird. Anyway, the next article is over on RealityHacker. Researchers make breakthrough in semiconductor technology set to supercharge 6G delivery, like self-driving cars, which eliminate traffic jams, getting a healthcare diagnosis instantly without leaving your home, feeling the touch of a loved one based on a location across a continent. Might sound like stuff of science fiction, but new research could make all of this and more a step closer to reality thanks to radical breakthroughs in semiconductor technology. This article is from May 22nd, 2025, but just recently aggregated into ohmTown. So new research led by University of Bristol and published today in the journal Nature Electronics could make all of this and more a step closer to reality thanks to a radical breakthrough in semiconductor tech. Co-lead author Martin Kubel, professor of physics at the University of Bristol, said that within the decade, or the next decade, previously almost unimaginable technologies to transform a wide range of human experiences could be widely available, and it's possible due to the new evolution of technology. It's a list of possible 6G applications is endless, with the limit just being human imagination, they say in this article. The shift from 5G to 6G will demand a radical upgrade of semiconductor technology. For instance, the main semiconductor components involved. In other words, the radio frequency amplifiers made from a wonder conductor called gallium nitride, or GaN. So like these these anchor chargers are really powerful. These like I buy these anchor USB-C chargers. You know, they pump out like 100 watts, but they're really small. They're GaN, and it says they'll need to be much quicker, emit greater power, and be more reliable. And the team of international scientists and engineers have tested new architecture, catapulting these special GaN amplifiers to unprecedented heights. So they're really just kind of hyping up gallium nitride, which pretty much anybody that's really into tech knows about, because that's what higher end chargers are using, gallium nitride. Although there's some that are LiFePO, a different type of battery chemistry. So they say they found a key aspect driving the reliability that was a thin layer of dielectric coating around each of the fins of their technology, and the latch effect can be exploited for countless practical applications, which could help transform people's lives. So they go straight from the tech straight into the human existence kind of concept here, instead of digging deeper into what this is really all about, unfortunately. But I don't always read the articles prior to the show. I typically don't, but I have some experience in all of the stuff we talk about to some degree. Sometimes it's very basic, but I really like all of this technology evolving and life getting better. I guess we'll see what the next decade holds. Let's keep going, though. Hopefully we keep moving forward. The next article is over in Greenogram, nerve to cancer transfer of mitochondria during cancer metastasis. So when cancer metastasizes, it basically spreads throughout the body. The study reports the development of a method to trace intercellular transfer of mitochondria, and demonstrates that cancer cells that receive mitochondria from neurons have enhanced metastatic capabilities. So the nervous system has, this article is over in nature.com. There are like 15 people involved in this article, so I'm not going to be able to go through all of it. They say that, however, the precise impact of cancer-associated neurons and the communication channels at the nerve-cancer interface remain poorly understood. Previous cancer denervation models in rodents and humans have highlighted robust cancer dependency on nerves, but the underlying mechanisms that drive nerve-mediated cancer aggressiveness. Aggressivity. It's hard to say that word when you don't say it regularly. Aggressivity remain unknown, or how aggressive the cancer is in terms of following a particular path. So they say in this article and in the associated research that they show how cancer-associated neurons enhance cancer metabolic plasticity by transferring mitochondria to cancer cells. So breast cancer denervation and nerve cancer co-culture models confirmed that neurons significantly improve tumor energetics. So they basically charge up these tumor cells to transfer, and neurons co-cultured with cancer cells undergo metabolic reprogramming, resulting in increased mitochondrial mass and subsequent transfer of mitochondria to adjacent cancer cells. So ultimately, what could be the precipitator of cancer is a contaminated mitochondria, and that would be a very interesting path to research. So to precisely track that fate of recipient cells, they developed MitoTracer, a reporter of cell-to-cell mitochondrial transfer that permanently labels recipient cancer cells and their progeny. Lineage tracing and fate mapping of cancer cells acquiring neuronal mitochondria in primary tumors revealed their selective enrichment at metastatic sites following dissemination. So once they received it, they had the ability to also energetically move to other cells based on my interpretation of this. And collectively, their data highlight the enhanced metastatic capabilities of cancer cells that receive mitochondria from neurons in primary tumors, shedding new light on how the nervous system supports cancer metabolism and metastatic dissemination. So yeah, quite fascinating. There is research now out there where they can replace mitochondria in cells, which I think is going to be the next thing. Essentially, they create superhuman mitochondria. Maybe they can replace the mitochondria in cells and basically cure cancer by not allowing mitochondria to metastasize cancers. All right, let's go on to our next article. This next article is over in Technology Today. Volcanoes may be spewing gold from Earth's hot molten core. They say volcanoes may be spewing gold from Earth's molten heart, but hey, I couldn't do ASMR. Scientists have uncovered evidence that precious metals like gold are leaking from Earth's core into the mantle, ultimately reaching the surface in places like Hawaii, using a new method to detect subtle isotopic differences in ruthenium. Researchers identified a distinct signal pointing to material from deep in the Earth core, and it challenges long-held beliefs about the creation of gold. The University of Göttingen put the article together. It's published over at Sci-Tech Daily. So now scientists may have found signs that some of the buried treasure is making its way back up. Over 99.999% of the Earth's gold and other precious materials, metals, lie about 3,000 kilometers underground, far beyond human reach. The particular type of ruthenium likely originated in the Earth's core itself. The findings were published in the Nature journal, the scientific journal Nature. I don't know how they know this. How do they figure this out? Is beyond me. So yeah, the breakthrough, they say, when the first results came in, they realized that they had literally struck gold. Their data confirmed that material from the core, how do they know? Including gold and other precious materials, metals, is leaking into the Earth's mantle above. One of the authors concludes whether these processes that we observe today have been operating in the past remains to be proven. Their findings open up an entirely new perspective on the evolution of the inner dynamics of our home planet. All right. I don't know how they know that it's from the core, but it is what it is. Maybe we're reproducing gold in the core, and eventually it'll make its way out. They say that it's making its way out via volcanoes. So maybe volcanoes will be the new oil. I don't know. Pull some of the lava and see how much gold is in it, right? It's an isotope of ruthenium, I guess, that they're detecting, but not actual gold. All right. Well, we are going to erupt back to the front page of Technology Today over at ohmTown.com, and where I'm going to shut down, and we're going to be back for FourWheelTech in just a few minutes. So see you soon. Bye-bye.